So, with timing being critical, I'm going to speed mine up a little bit, just 5–10 minutes. Just keep it high level and fluffy. If you've got any questions, I'm going out to lunch with you guys after so we can talk more, right? So, we are announcing Gen-3 fast silicon carbide MOSFETs. We have Gen-3, and we're going to our fast portfolio, a high-speed portfolio. And we'll discuss this a little bit more. So, Navitas' GeneSiC product line, we have 650 volts all the way to 6.5 kV. So we have a very broad voltage range portfolio of silicon carbide for both MOSFETs and diodes. What we're going to focus on, and that's what we're targeting for our high-speed portfolio, is 650 volts and 1200 volts. Right? And as you can see also, we're doing a toll package, which Charles was talking about before. We're using that for silicon carbide as well. We have a slide on that. I'll briefly talk about it. Not to go into too much detail, but this is the semiconductor market split by GaN, silicon carbide. You can see anything up to 650s kind of GaN. 1200 volt is SiC. And in that middle area, you have that 650 volts, which could be SiC, could be GaN, it can be both. And now Navitas has both silicon carbide and GaN. We offer both solutions, and we'll show a reference design which offers both the GaNSafe and the Gen-3 fast silicon carbide in a data center CRPS system. So the areas we're focusing on is that 650 volt area and the 1200 volt area, where high speed or increasing the switching frequency brings a lot of benefits, both in efficiency, power density, in cooling, and ROI. And that's one of the key things why we released this Gen-3 fast high-speed portfolio. So target markets, these are our key target markets. It's the EV side of it, the OBC, the DC-DC, anything with that 400 volt battery. That's where the 650 volts comes in. Also, data centers, very key for high speed, where we can reduce the magnetics, increase the power density and efficiency. For the 1200 volts, it's the same. It's EV, but it's for the batteries with 800 volts. So it's OBC, DC to DC. Also, e-compressors. You know, anything in an electric vehicle needs an electric motor, so compressors is one of those, the HVAC system. But also then we're going into solar energy storage systems. So, portfolio. And I'm purposely talking this fast so we can speed this up a little bit. So we have a 650 volt range, 25 milliohms up to 60 milliohms, and the 1200 volt portfolio from 20 milliohms to 75 milliohms. And again, we have those different TO packages, which are classic, and the toll package, which we'll talk about in a minute. Now, Sid before talked about the technology of our trench-assisted planar gate for GeneSiC. And I won't talk about it much, but the point is, what we do with our trench-assisted planar gate is we compete with the silicon carbide trench gates for the switching frequency, but we also have the lowest RDS-on shift versus temperature across all the technologies. So we really bring the best of both worlds together. So what does that mean? Now, on a data sheet, like I mentioned before, we do like 25 milliohms, 20 milliohms. I haven't got a pointer, or have I? No. So on a data sheet, it will say 25 milliohms. But once you start switching the device, there's heating internally, right? The temperature keeps going up. It's in a box. The ambient temperature keeps going up. It gets hotter and hotter until it kind of plateaus. Realistically, you're switching around this area. You're not switching at a data sheet. So when people compare data sheets together, the 20 milliohms is just a number, right? It's really what's happening over here is where the action's taking place. And you can see that GeneSiC has a 15%, at least 15% to the best competitor, more for the worst competitors, of lower conduction losses. So that means the device runs cooler. Cooler means higher reliability, but also you can ramp it up a bit and give it more drain current. So you can actually give it 13% more drain current, it's higher power density. So that's the benefits of this lower RDS on shift with temperature. And that's what the GeneSiC patented technology brings. Okay, just briefly, we test our parts 100% avalanche tested, so we stress test them, not too much, we test them so the screens, so the parts you get are very good. We've got a very stable threshold temperature, so in the modules, like those big EV modules, when you have to parallel maybe 12, you have to make sure you get a very stable threshold for current sharing. If it's too low, it won't share properly. Then you get a nice even sharing VTH, it means it's very good for high power modules. And then with our patented design, we offer a 30% long short circuit withstand time. Now, very briefly, Hal already talked about the design centers, and I just want to talk a bit more about the data center. We call it the CRPS, and we made this. These guys made a 3.2 kilowatt design. I'll talk briefly, and also a 22 kilowatt for OBC. For the 3.2 kilowatt, on the front end, we use the Gen-3 fast for the totem pole. For PFC, sorry, and then for the 650 volts on the LLC with the GaNSafe. Now, the data center server power has this new efficiency requirement, which is called Titanium Plus, and it requires to be over 96%. And I'll point over here with my laser finger that we can achieve, into that 98% range. So we're achieving that super high efficiency, very high power density, great for cooling, all with the Gen-3F and with the GaNSafe. So we're very proud of this. Now, if you look at the devices in the system, what it shows is, as I mentioned before, we have the lowest RDS on across all the temperatures due to our design, but also we have a very low switching losses in comparison too. So again, we have the best of both worlds with this technology. The toll package I'll touch briefly on. We have a very fast device. We need a very fast package. And Charles talked all about the toll. I'll just mention that it has a very low package inductance of 2 nanohenries, but also from the PCB area, it saves 30%. And customers like this to make everything smaller. We also have a 22 kilowatt OBC design using the Gen-3F or Gen-3 fast. Very high efficiency, very high power density is one of the leading examples in the market. Right, last 3 slides. Product support, we have a lot of product support. We offer SPICE simulations, the resolution's not so good here, but we have SPICE, we have Plex for anyone wanting to do faster design cycles. And also, as I mentioned, we have this whole system center, so we're very system-centric with our customers. And this is the last slide. There you go. So as I said before, from 650 volts to 6.5 kV, we have a real wide portfolio across all the voltage classes, and now we're announcing our fast silicon carbide MOSFETs. That's it. There you go.